A very pleasant evening one and all. Today we are going to see the topic of how interfacing requirements for the microprocessor and microcontroller. What is the interfacing requirement? Interface is the part for communication between two components. Interfacing is of two types: memory interfacing and input-output interfacing. And what is memory interfacing? When we are executing any instruction, we need the microprocessor to access the memory for reading instruction codes and the data stored in the memory. For this, both the memory and the microprocessor requires some signals to read from and write to the register. The interfacing process includes some key factors to match with the memory requirements and the microprocessor signals. The interfacing circuit therefore should be designed in such a way that it matches the memory signal requirements with the signals of the microprocessor. And I/O interfacing. There are various communication devices like the keyboard, mouse, printer, etc. So we need to interface the keyboard and other devices with the microprocessor by using some latches and buffers. This type of interfacing is called as an I/O interfacing. And how we are going to map with the I/O, memory mapped I/O and I/O mapped I/O. The microprocessor cannot do anything by itself, therefore it needs to be linked with the memory, extra peripherals or I/O devices. This linking is called the interfacing. The interfacing of the input-output devices in 8085 can be done in two ways. One is memory mapped I/O interfacing and I/O mapped I/O interfacing. In memory mapped I/O interfacing, the kind of interfacing we assign a memory address that can be used in the same manner as we use a normal memory location. And in I/O mapped I/O interfacing, it is a kind of interfacing which we assign an 8-bit address value to the I/O devices, which can be accessed using in and out instruction, is called I/O mapped I/O interfacing. This is simply called as difference between memory mapped I/O interfacing and I/O mapped I/O interfacing. The major feature is addressing, address size, instructions which are used, and cycles and registers communicating. And what we are addressing I/O devices are accessed like any other memory location, whereas in I/O mapped I/O they cannot be accessed like any other memory locations. And address size, they are where memory mapped I/O were assigned with 16-bit address values, whereas I/O mapped I/O devices are assigned with 8-bit address values. And what kind of instructions we are used in memory mapped I/O is, the instructions used are LDA and STA, etc. The instruction used in I/O mapped I/O is in and out and cycles, and the cycles involved during the operations are memory read and memory write, whereas in I/O mapped I/O cycles during operation are I/O read and I/O write in case of I/O mapped I/O. At the registers communicating, any register can communicate with the I/O device in case of memory mapped I/O, whereas only accumulator can communicate with the I/O devices in case of I/O mapped I/O. Whereas and the major differences concluding are space involved. 2^6 I/O ports are possible to be used for interfacing in case of memory mapped I/O, whereas in I/O mapped I/O only 256 I/O ports are available for interfacing in case of I/O mapped I/O. 2^16 ports are involved for space involved, and 256 ports only available in I/O mapped I/O. And IOM signal during writing or reading cycle, I/O power m I/O bar m is equal to 0 in case of memory mapped I/O, whereas in I/O mapped I/O, IOM bar m is equal to 1 in case of I/O mapped I/O. Whereas in the control signal, no separate control signal required, since we have unified memory space in the case of memory mapped I/O. whereas in special control signals are used in case of IO mapped IO. Arithmetic and logical operations. Arithmetic and logical operations are performed directly on the data in case of memory mapped IO, whereas arithmetic and logical operation cannot be performed directly on the data in case of IO mapped IO. And 8251 USART. The 8251 USART, universal synchronous asynchronous receiver transmitter, acts as the mediator between the microprocessor and the peripheral to transmit serial data into parallel form and vice versa. It takes data serially from peripheral and converts into parallel data. After converting the data into parallel form, it transmits it to the CPU. Similarly, it receives the parallel data from the microprocessor and converts it to a serial form. After converting the data into a serial form, it transmits it to the outside world or outside peripheral. Thank you. In next class, we can discuss on the block diagram and the architecture of 8251 USART. Thank you.